Hello everyone, we are back. And the speaker for today is Arndt Bitchen. Well, he's not only just a speaker for today, he's also my colleague, and that's why very dear to me. And so let me give a very quick description about Arndt. So Arndt is an experienced project manager with over 20 years of experience in managing construction projects. So he's currently the managing director of SMV Bau Project Steuerung, Hamburg, where I work actually. And he's also a teaching faculty at the HTW University, and he was also the ex-president of ICPMA and is currently the member of ICPMA. Today, he's going to share his insights about how we can go forward with the sustainable projects and how we can achieve sustainability. So, ladies and gentlemen, I present to you Arndt Bitchen. Arndt, the stage is yours. You can go forward.
Okay, thank you very much, Margit. Thank you very much for the invitation to speak here, to have the chance to do it, because this is a very interesting, very important topic, I think, for us and as well for the future generations in construction industry. Therefore, yeah, let's go ahead with that. So first of all, to give you some impression of what I'm going to talk about. So Angelo, thank you very much for your presentation. So I think it has, in the end, much to do with it, with the things that I'm saying. But I tried to keep the focus on the experiences that we were able to make in the projects that we were working on in sustainability. So which we in Hamburg were working on for SMV with our clients. So therefore, I tried to work out some experiences that we were able to make when working in this sector and trying to create, design, and realize buildings that meet sustainability goals and even the zero carbon emission, so that as well the Edge software tries to certify. So table of contents. Just to get you around the corner, what is sustainability? Very short and quick view on it. Why do we really urgently need to talk about these things, and why should we all promote the sustainability movement? Let's say that way. So then, trying to get a rough overview of the fields to consider in construction when implementing sustainability. I know that's a very, very huge field, and I would try to focus on a couple of things that that turned out to be relevant in the projects that we were working on, or currently are working on. So then, two case studies. There's a new innovation center in Hamburg and another urban development in Lower Saxony in northern Germany, where we have made some experiences regarding design layout materials and technical concepts. And in the end, for sure, you will, I think that's the reason why you're listening, is that the lessons learned. So what is the experience that we made and what are the things to consider? I think there's a couple of things that you already know, but anyway, so probably we can share something and learn from each other. Good. What is sustainability? Preparing this presentation, I went to the Cambridge Dictionary. You can see what they say. It's a more general thing that this ability to be maintained at a certain rate or level. But what we mean is sustainability to exist constantly. The interesting definition that we found out in the UK Department of the Environment is the following one, so that it's really has to do with the future generations. And I think this is exactly what it's all about. So I don't know whether you have children, I do, and I think at least minimum for them, we have to do it to succeed. Yeah, need for sustainability in construction on the left side. So this is very cute bear, but these pictures very frightening. So you all know that I won't talk about the things standing below the this picture, but the important thing is, and this is a leverage that we have, is that about 40% of the energy-related greenhouse gas emissions are from buildings and construction. So, and if we realize that, so then we have the knowledge that there is a field so that we can really move forward with that, so that we really can make the difference probably. And even though when you consider that the demand for housing and working space is predicted for the next decades to increase extremely because of the increase of population as well and all the needs. So then we really need to keep an eye on that and think of how can we go into lead with our industry and really to make the difference and to change the world. So let's act. The fields to consider in construction. So I know this is only a very, very brief bullet point page here. I think it has enormous range where we could start to work with. Okay, let's try to sort this a little bit out and try to find some topics. So it's clever user requirements. So that means so we need to check if this sometimes traditionally user demands and requirements are really up to date, or whether they need amendment, especially when we try to reach the goal of sustainability and CO2 carbon dioxide neutrality. So that is the key to sustainability. So then we have the use sustainable materials. So I think this is quite obvious. The wood, eco concrete, all the things that with less CO2 footprints or embodied carbon in the best case. So then the state of art building shells and so on. For sure, we need to take into consideration that in Germany, where these two case studies are now taking place, we have certainly a different climate, but I think we can copy that somehow, amend it to other parts of the world. Then use passive cooling methods, natural ventilation, open patches, green roofs, natural light, and all that stuff to reduce the energy consumption. Clever climate engineering, reducing the use of high CO2 producing technical equipment such as air conditioners and so on. Overall, what we need to do besides the embodied carbon materials, if possible, is to reduce energy consumption. I think this was very, very clear as well in the presentation from Angelo, that this has a very big leverage, and that's in the end to create CO2 neutral buildings. So what can we say when we're looking a little bit further into the details when about the project and design phases? Yes, we have two case studies brought with me. First of all, the one is the New Innovation Center in Hamburg, which you can see rendering on the left. The architect was Lava, Laboratory of Visionary Architecture in Germany. So they are located in Germany and Australia. So we were asked to do a feasibility study with the planning team, which consisted of climate engineers and so on, architects, and the normal batch of engineers which you need for these projects. It was a space of about 20,000 square meters above ground, a 3-story building with a basement underneath. So it's a different building type. So, and that's the reason why it shows this, because it has lower requirements regarding the authorities, regarding fire protection and so on. And the second one is a high-rise building, which has other regulations and needs for fire protection, and therefore it has a little bit different approach. Yes, the goal here was a CO2 neutrality. Try to realize it as well for the construction period, and not only for the using period or operation period. In the end, so we were pretty close to this goal. But anyway, so let's talk about it later. So it was a multi-use building that was supposed to be a prototype for a learning center for lifelong learning period for all the ages and generations and so on. And you can see kindergarten, school, primary, coding lab, makerspace, canteen, health center, gymnasium, sports center. So everything under one roof. And you can see on the pictures already, we have a lot of wooden construction used here. We have a maximum of natural light. We have wood hybrid construction. So all these sustainable highlights that I think we know, are very common at the moment in the industry. And I think this is quite a good movement. So then we have for sure a basement, and the coarse planting concrete. So that has the reasons for the material is better for these parts. The maximum ventilation already said. Then we have provision of photovoltaic panels on the roof for the energy supply. So then we have a certain design of this building, which we are coming to, which was developed to get much light in it, much green in it, to optimize the microclimate inside and outside. So let's take a closer look on some things that we found out. What you can see, I hope you can see it very clearly, because the picture on the left above is not that good. But so we started with some workshops and really trying to define how can we go through the design process in the best way. How can we organize the building, which has a very, very high depth in space, that way that we can maximize the natural light and reduce and optimize the artificial light. And this was something that we tried to find out as well with climate engineers, with the architects, with us. And you can see it on the left side on the rough picture, that it's more or less on the right side of this picture, the onion system. It's more or less like putting all the areas which need a lot of natural light because of operation time during the days, so like the school rooms and so on, or offices for the administration, all that stuff. So to get that to the facade. So then in the other parts where it's even darker, because it's more, you have the depth of the building. So then you have other areas that don't need so much light, or which are running most of the time, or which need artificial light because of operation times that lay as well in the later afternoon or evening times. So, and this is how we analyzed this with our climate engineers, Transolar, is that, okay, how can we bring the light into most of the places? So, and now we're following from left at the bottom, from left to right, from top to bottom in the building. And you can see here that we have organized a lot of skylights here, which you see the yellow marks. So it's just to explain the colors. It's yellow is for sure maximum natural light. So, and then it goes down to blue. Blue is pretty dark. So that's the reason why we implemented here to cover this space with natural light. We implemented skylights. So, and then when you go down one floor down to the first floor and as well to the ground floor, you can see that in the center of the building parts, there are zones with which are pretty dark and which you have difficulties to get light into. So, and that is the reason why, if you look into the presentation, you can see these gray small lines which tell you about where are the cores located, where are some performing spaces, or where are some kindergarten gadget lab makerspace, which you normally use artificial light. So these things are put into these sections, and as well what we developed because of this study, we implemented these patios here to bring to serve for the light, to bring it into the building, like a very traditional way, which you know probably from some 100 years ago. But it's really a very interesting thing to bring the light into the building. Next up is, okay, how can we use the natural air ventilation system? You can see a section again from this building with all these usages, and you can see that We try to bring even more a lot of natural light into the building. No, natural light, natural ventilation into the building, natural air supply, which is best, but not ducted in that way, so that we put it in through ducts and then we distribute it. But we take the intake via the facades. We take the outtake is then via the patios and the skylights. So for sure we need energy recovery systems to not to avoid heating energy in the building, for sure, that's clear. But so this is more a symbol of, okay, how can we work with that? And as well, even in summertime, you can really open the facades and get during the nights the cooler air into the building. And in the winter time, okay, for sure, then you do it a little bit different via this elements in the facade. Yeah, for sure. The next thing is the materials. I think this is more or less something very, very known, and that's the reason why I'm not trying to go so much into detail. So you can see here the calculation of, okay, the embodied carbon rate in the building. So for the 3-story construction, you're allowed to execute a lot more in wood than in other higher buildings due to the authority regulations and fire protection rules in Germany. And that's the reason why we had a very, very good rate here generated in the building. When we are talking about this materials, so we focus some challenges. So everybody knows that wood, first of all, is prone to fire, although with a certain thickness, it can do a little bit more. Has a big fire resistance against than steel or something like that. But in the safety zones, it's forbidden, like the staircases and so on. So then, for sure, something that we really need to do, and probably we can talk later on, is to promote as well the benefits of such systems as the prefabricated elements with less time of assembly on construction site. Okay, we need the prefabrication times, but for the project, it can be beneficial and a little bit quicker. Wood is acoustic sensitive, and several layers of insulation are required for soundproofing. This turns out to be a very, very crucial point, as depending on the usage of the rooms in the different stories, we have found out that we really hard fighting to find solutions to get this sound protection between stories, between rooms and apartments done. But therefore, we need some mass, and this is the system that that our static engineers, SPP, developed together with the architects. It's a hybrid system of wood, so the beige ones are all wood elements, and the rest mostly is and the gray is concrete. So you need some mass in the building, and this as well for sound protection. So therefore these elements as well for the static system as well for fire protection reasons are combined, so that you have a very good system, but with mostly wood where it is possible. Yeah, next up, so what we for sure did is that our climate engineers, they run a energy demand modeling model to find out how our energy consumption is really looking like. And you can see, so we're coming from above, during this feasibility study from right from the start, when we had less data and when we had less elements from the technical concept implemented. And you can see then that we have we need to reach the green fields, let's say, the green data and we were reaching in the model of the end of November, we were overrunning this because of the limited space of photovoltaic, because of the very, very high user demands regarding the canteen. So it was a very traditional one with a lot of high energy consumption equipment, and this exactly was one of the biggest points. So that we discussed in a couple of meetings. So how can we adopt the user requirements to be able so first of all, without reducing the comfort, but probably with reasonable changes to be able to really reduce the overall energy demand of the building, so that it is able to be covered. So, and this is we listed these and as well did another another energy demand model, and which came to the result that if we are able to change the user requirements and therefore the energy consumption in the building without really cutting off essential comfort, so then we are able to reduce these energy demand to a rate that we are able to cover by CO2 neutral carbon energy self-supply. And if we are not going that way, so we could do it during operation time. Good, so this was the first case study. The second one is this urban development in Lower Saxony in the northern part of Germany with the architect Henning Larsen. A very, very huge building complex with about 90,000 square meters grass above ground, up to 8-story building. So with like terraces and all the things that you can see on the rendering on the left. And the usages as well, multi-use with offices, residential, hotel, leisure, food, retail, and our parking garage. So we need that still, as the political background is still not adopted to the needs that we will that we have already regarding sustainability. Here as well, the goal was CO2 neutrality, but already known that with high-rise building, we have another ratio of like roof or photovoltaic, and another intensity of or density of use. So our main focus would lie on, first of all, for sure, the shell that is optimized, then optimized design, but as well with a focus on the operation time. Yeah, you can see here now in this picture on the left, like this overall strategy. So I think this is nothing new to you. Yes, but we are talking more and more about user comfort, how we can do it. And I really have to say, and I'm very convinced that we can reduce the traditional user comfort and replace it with a new level of comfort, which is much better and needs less energy. So, but anyway, the sustainable highlights of this building complex, which we are still planning on, so we're not succeeded yet, but we are on a good track as we think, is that we'll have a wood hybrid construction here as well, basement and cores planned in concrete, a maximum natural ventilation, provision of PV panels on the roof. We have green roofs. We have decentralized cooling systems. We try to decentralize the systems in a reasonable way. There are some areas which are not able to be centralized or not beneficial. And then we have for sure the green aspect, the plans for healthy microclimate. Yeah, we're coming then to the design layout again. So you can see here the sketch from the architect. So it's always interesting that we have like forests on the roof. So this is for sure a little bit exaggerating. I think everybody knows that, although I think in Asia, so there are some buildings to find where they really realize that. But then I think they are mostly not built of wooden structure underneath. So this is something that we really learned as well. So that this is, that's an idea behind that, so that we have this pixeling of these terraces to create another scale, human scale, for this urban design. But anyway, besides this design issues to reach this human scale, so we have the integration of the green roof into the multi-story. You can see on the left then the different heights of the cube shaped through the structure that helps providing the natural light to a little bit more rooms, probably, and as well to all the corners. And so this is as well following the reduction of the artificial light and the energy consumption. Just what we learn here as well is that the load management, which I would say, or which I need to explain, the wood management is the thing that we really have to keep in mind, that we think of whether we need 5 kilonewton per square meter in every story, or whether we think that 3 is enough. And probably we convince people really to think of it, probably to find solutions, or probably to convince them to accept that to live in a better building needs a little bit different mindset. Yes, what I already said, high-rise buildings often have increased fire protection requirements on facade, escape routes, and sprinklers, and this is something absolutely different compared to the other case study. Yeah, so some challenges that we were finding out is that we have, you can see here the structure elements of this building. So we have 8m10 and 8m10 in 2 dimensions. This is the normal grid, which is with a rotating of the adjacent elements. And we have, you can see here, the gray things are the staircases and the cores, which are here in a very early stage shown, which cause a lot of elements that are not normal elements. So, and therefore cause a lot of trouble, not even for production, but as well for execution later on. And so this is something that we changed. So then you can see here the evolution of the grid system. So we started with this, and you can see on the picture of the 4 ones on the above left, you can see here the problem of the duct and alignment pathway, which have a collision causing it with every single beam. This is something that we found out that is probably not the way to construct it. It will cause a lot of trouble with all the openings that we need to foresee in the wooden beams, and wood is different from concrete, so that you're really not able to react on construction site. So this risk is something that we don't want to take. So in the other direction, it's not a problem to do it. We have the concrete layer, the concrete slab with a junction and combined with these beams. But as well, when you consider to have an aisle wall as well to combine with this grid and with all these beams, so you really find yourself in absolutely mess regarding the sound insulation questions. That's the reason why, even though in all these areas of the where we have hospitality, like apartments, like hotel, so we were switching now to this system on the bottom left. So where we still have a wooden slab but plain underneath, so that we are able to really solve all these joint problems and acoustic problems, and as well the alignments of the ducts. Yeah. So next, where we're coming to the technical concept, we try to do quite similar than in the first case study. We have this elements and the facades with which really bring us so decentralized elements would help to reduce the central spaces and all the ductworks and all these stuff. Yeah, have some difficulties in not overrunning the 18 centimeters height or 20 centimeters height, not to come to another rule and not to for another technique. So then the technical concept for the office is probably something very interesting that we have in mind, that we will have here some fans visible, which cause a noticeable breeze, like the chill factor, so which cause moderate investment costs. We have minimal operation cost, maintenance-free system mostly. As well, what we find out is if we have an effective planning and control of alternative ecological fit-out materials, we will be able to reduce air exchange rates. Cooling overnight with outside air during summertime, and it's quite the same as we had it in the other project. And you can see it here, so as a sketch from Transolar as well, how this could run then. And another point is here, so that we as well try to implement a cooling system into the ceiling, an integrated cooling system, but this is something that we are still working on, because if you have a wooden structure underneath that, so you can see here the concrete, with concrete it's not a problem, but if you have a wooden structure, you will need to implement another system. So, and this will be a very interesting challenge to find a solution for that in the apartment and hospitality sector. Yeah, technical concept. Yeah, interesting is that we are always talking about, first of all, how can we build up a shell and building structure which is like sustainable already, has very good, state-of-the-art parameters and all that stuff, and as well to reduce all the energy consumption. And if we did this already, so then we can as well run again the energy model, and then we can see that in the end, when with already reduced and optimized energy consumption, we are here talking about the operation time. And so you can see here in the middle, so this is the conventional building, or the conventional technical concept with central air supply units, and this is the one that we planned, that I explained to you, the one in the middle, and on the right you can see this is quite the same, but only the energy supply is coming from outside for a dedicated element like a windmill, something like that, from sustainable energy. So, and then you can really reduce as well these very quickly, and you can come to very quickly to a really zero carbon building as well in this size. Yeah, so how to proceed on the road to CO2 neutrality, lessons learned. So I was putting here all the topics, all the facts that we already talked about. So let's go through it very rapidly. So we use material with embodied carbon whenever possible, whenever reasonable and justifiable. We think local requirements before implementation. Load requirements, respect material-specific advantages or disadvantages. So I think that's quite important. Create a strict modularity in design, and to keep the challenges on site at lowest level possible. Concrete respects wood, because this is something, the concrete you can really form. I think in Spanish it's hormigón, and then you understand that it's something that you can create and shape without limits almost. So the rotation structures cause a lot of trouble. So this is something that probably is not the right thing. One direction is something that is probably more appropriate. Sound protection issues have to be solved very early, and that has an impact on planning details. detailing in the first phases. Fire protection, everybody knows. Integrated green concept to create healthy microclimate for sure, and for sure support intelligent green mobility concept for the exchange of the surroundings, political elements like people coming with bikes and all that stuff. The planning process to consider is an earlier integrated and detailed part. You need to think some things take these from the execution planning to the design planning already. Otherwise, you cannot solve the problems early enough. And as well for the technical concepts, the reduction of energy consumption is key. That's not our invention, but so if we do it consequently, so then it's really the point. Change traditional mindset for user requirements, create a new level of comfort, and then you can go ahead with the technical climate engineering, maximize green self-supporting energy, maximize natural ventilation, natural light zones, and minimize cooling load ventilation. Yeah, saying that, so we are through. Thank you very much. I hope I was able to share some experiences with you. Probably you have made yours, and I'm very happy to receive your questions now. So let's do it. Take the next exit. Thank you very much.
Thank you, Arndt, for sharing your insights with us. I would like to request you to just mute yourself for a bit, because otherwise there will be echo problems with us. So yeah, I think it was a quite interesting presentation, and somehow we get an idea, like if we talk about sustainability, how we can actually go forward with that, because it's one thing to constantly talking about that we want to have a green building, but the challenges come when you try to set up a design or you deal with the technical problems for the day-to-day activities. So I think our attendees had a lot of fun, and we have a lot of questions actually for you. We won't be able to take all of them right now because of the time constraints, but one or two we can suffice. So the first question is from Nick, and he says, how do you try to encourage the clients to embrace the sustainability agenda if the client thinks the cost will rise? Do you rely on regulations to force the sustainability agenda? What's your take on that?
Yeah, the interesting thing is that with these case studies, we have the luck that we have already clients that see that sustainability is something not only to think green. To think green like 30 years ago, and when the Green Party in Germany raised up, it's more or less like crazy people that are talking about the green planet. So they really found out that this is, first of all, a holistic issue, as well. For this, for the first case study, it was more or less a mindset. It was a philosophy. Why to go this way, take this road, and even though to do at least a feasibility study, and try to see how far we can get. In the second case study, it's more or less as well so they are convinced that if they really will succeed with this, because a building like this in Germany doesn't exist yet, even though it's of the size and as well of this combination of use. They are convinced that in the end, when you have are able to reduce the operational costs in that way that we are trying to achieve, that it really will be beneficial for them. Although they know as well that they need to invest more money, because actually momentarily this way of construction is a little bit more expensive. So we know it, everybody knows that.
Thank you, Arndt. So maybe two more questions we'll take. So one of the questions is from Christina. A quick question. Is the pandemic and its consequences impacting sustainable design or sustainable construction in any way?
I would say, to be honest, at the moment, nobody thinks, we are not really thinking about that. So I think it's more or less it's something that we need really to think about. So whether this pandemic will come to an end, like there are other diseases that we have control over, or whether this is only one of others to come, and which probably will have then more impact on design process, on space demands, on organization of spaces, and so on. So I'm not quite sure whether this. So in these projects, so the first one was done without the pandemic experience, let's say it that way. The second one, I think it's really not an issue at the moment. Let's say it that way. As far as I'm involved in these discussions.
Thank you, Juan. One more question from Mika, and he says, what do you think? Is there enough sustainable wood or forest in Central Europe to add use of wood, or is there shortage of wood and sustainable forest already?
Very interesting question. So this is something that I ask myself as well, to be honest. So if everybody would go that way and build in wood construction, or wooden construction, so probably we will have as well to face this question. The problem is, so I recently listened to the report from the Ministry of Environmental Issues in Germany that a huge amount of forest was damaged because of the water that is missing, and the drying periods, and all this, and this really makes us think about, okay, do we need to reorganize this wood industry if we want to go, let's say, go green with wood constructions so widely as it would be necessary? But this is really a good question. I think at the moment we don't have a problem, but we need to think carefully in which direction we go, in which how broad we will get, and then to see is there really enough wood possible to build in.
I think, that's a concern that we will be thinking about maybe in coming years. And I think Mika posted the question because he's from Finland and they have a lot of wood. Am I right, Mika? Yes.
If I'm able to say something, probably Mika can get some trees for me still for the next project that I will have privately.
Yeah, I think that would be good. Okay. Thank you, Juan. That was really wonderful and a nice conversation we had. We still have a lot of questions, but we just have like 5 minutes for the next session. So we'll put up those questions in the open forum round, and we'll have you back to answer all the questions. So once again, thank you very much. I hope everybody's having a wonderful time, and we'll see you in 5 minutes as our new session starts. Yeah, thank you once again.
Thank you.